Hey guys, and welcome back to a new video and to part 2 of the Bluetooth chat playlist, in which we are building a fully functional Bluetooth chat, so a chat app that works via Bluetooth so you can chat between two Android devices. In the last video, we built this screen to actually scan devices and display paired devices. So if we click Start Scan, then you can see all the devices here in my environment are actually displayed. And we can also stop this. In this video, what we'll cover is pairing and connecting devices. So once we found a device you want to connect to, we can then click on that device and we actually see a little connection spinner. And yeah, we see two pairing dialogues on each device. And when they both accept that pairing dialogue to pair it, then yeah, we will be able to chat. The chat functionality, so actually exchanging messages via Bluetooth, will then be part of the last part, which will be part 3, which will come on either the next Wednesday or Sunday, depending on when this video comes online. And if you have not watched part 1 of this and you just care about learning how you can pair and connect Bluetooth devices, then you can also watch this video while skipping the first one. You can get the code, the initial starter code for this video in this video's description. But if you care about learning the whole picture of Bluetooth, then I really recommend watching the first part first, and then this one, and then the next one. So let's jump into our Android Studio project. And first of all, I want to go to domain in our Bluetooth controller interface. And in here, what I want to do is want to extend this with 3 more functions actually. On the one hand, I want to have a function to start the Bluetooth server, because the way Bluetooth communication works in Android is very similar to something like WebSockets, where a remote server actually launches a server and receives connections, and then your phone or your device can connect to that remote server. And there will actually be an active connection between these two devices. And Bluetooth works very similar. So here one device, one party needs to run a server which accepts connections, and the other party can then, in our case, click on that device and connect to it if that server was launched. And after that the connection was established, so after pairing was successful, all that stuff, we have an active connection and we can exchange bytes. So either party can send bytes to the other party. So will this function actually take any parameters or return something? Yes, it will return something. And before I get into specifying the return value, I want to create a little helper class. In our domain chat package, I want to create a class connection result, which will be a sealed class, or actually even a sealed interface will be enough. Yes, let me add that to Git. And in here, we will just define different types of connection results. So what can happen during our connection? On the one hand, of course, when the connection has been established, we want to send an event. When there was a connection error, we want to send an event with a corresponding error message. And in the next video, we'll also extend this with a class that we send when we actually received a message from the other party. So first of all, an object connection established, which will be a connection result. And then a data class called error, where we can pass the error message, which will also just be a connection result. And then in our Bluetooth controller, this start Bluetooth server function will return a flow of type connection result. Why a flow, or what is a flow actually? A flow is a reactive data structure. So the way this will work is, because if we start a server, this will be a blocking action. So as long as we actually wait for a device to connect, and then after it connected, as long as the connection is active, we really want to keep on listening to these events. Because as long as we have that connection, it could of course always be that a message comes in, and there needs to be some kind of background thread in our application that keeps on checking for that and notifies our UI later when there is a new message or when one device actually disconnected. And for that, it will just be very handy to create a flow or return a flow here, which then gives us these connection results whenever there is a certain change in our connection. On the other hand, we also want to have a function to connect to a device, where we pass the device you want to connect to, and make sure to choose our domain model Bluetooth device here. And that will also return a flow of connection result. What is the difference between these two functions? Well, the first one will simply launch the server. That is what device A has to do. And the second function will then be executed by party B, which connects to a device that has a launched server. But both these devices could then receive connection results when the connection was established, when there was an error, when there was a message received from the other party, and things like that. And last but not least, we want to have a function down here to simply close the connection. So when one device actually disconnects, we simply want to close the active connection to make sure the other party will also know of that. And then the next step is to implement these three functions in our Android Bluetooth controller, so in our actual implementation of Bluetooth controller. And let's do that here below Stop Discovery. On the one hand, we have our Start Server function. We have our Connect function, connect to device. And we have our function to close the connection. I want to start with the Bluetooth server, and I also want to replace this with our type alias, so Bluetooth device domain. So start our Bluetooth server. What do we need to do here? In the end, we need to return a flow, of course. So we use the flow builder, in which we can now call emit. So every time we call emit, this flow will emit a value, and we will then be notified about that later on in our review model. So one emission could be the event that our connection was established. Another event could be when we received a message from the other party. And that is why a flow will be really handy here. First of all, I want to check if we actually have permission, and if not, we want to throw an exception. So if we don't have the permission, manifest permission Bluetooth connect, because we execute this if we want to connect to a device or if we want other devices to connect to ours. And then we want to throw a security exception where we just say, okay, no Bluetooth connect permission. Then after we have made sure that we have permission, we need to use our Bluetooth adapter to launch a server. And we do that with the listen using rfcom with service record function. And you can see that returns a Bluetooth server socket. And in this function, we need to pass a name for our kind of Bluetooth service that accepts connections and a UUID, so a unique identifier. For the name, I'll just choose chat service. And for the UUID, I will create a little constant down here, companion object, and here we have a const val service UUID, and we set that to any type of UUID. I will paste mine here. You can choose any type of UUID. The reason we have to pass this is just that both parties, so both devices, need to share the same ID. But because we install the same app on both devices, both these apps use this exact UUID I generated here, that will be totally fine. But again, you can choose any value you want here. It's just important that it is in the UUID format, so with these dashes in between. And you can just go to an online UUID generator, generate one, and then use that in here. Just one thing you can do here is that you can go ahead and say UUID.random UUID to generate one using this function, because then each device will generate a random UUID at runtime. So both devices will have a different one, and that will mean you can't connect. So you really have to choose a hard-coded UUID here, but which one you choose is really up to you. So in here we can then say UUID.fromString, and we pass our service UUID like this. And we successfully now launched our server. One important thing is that we do care about the return value of this function, which will be a Bluetooth server socket, as I showed you, and we want to save this in a public field. So let's go up here, have a private var called current server socket, and that will be a Bluetooth server socket, nullable and null by default. We also want to have that for the client, so let's also create that right away. Current client socket, this is just a normal Bluetooth socket, so not a server socket, obviously. Let's then scroll down to our start Bluetooth server function, and we save our current server socket in here. So we save the return value in our current server socket. Cool. Now we actually started a server. What is now the next step? The next step is to actually listen to other connections. So we now really want to block this background thread as long as we are open to accept connections. And for that, we will use a while loop to just keep on looping. First of all, having a variable should loop, which is true initially. So just whether we want to continue this loop or not. And while we should loop, we then want to accept connections. And we can do this with a try and catch block. So we're going to catch IO exceptions, which will just be thrown if there is an issue in our connection. For example, if one party actually disconnected and the stream was interrupted. And in here, in this try block, we want to use current server socket that accept. Accept is really a blocking action here, so it will block the thread as long as we actually have this current server socket active. So as long until we call current server socket that close. That of course would need to happen from a different thread, since this one will now be blocked as long as we wait for connections to accept. If we catch an exception here, we simply want to return null. And first of all, we want to set should loop to false. So we just make sure that we abort our current server connection. Then we actually want to assign the result of this to our current client socket, because this accept function, if we take a look here, will return a Bluetooth socket, and that is now the socket from the client that connected. So as soon as we have a connected client, this function will return and this loop will go on. And we can then say current client socket is equal to this resulting socket of our connection, because this is the socket we can then use from the server's perspective to send something to the client. After this try and catch block, so after we accepted the connection, we want to then use our current client socket, check if that exists. And for now, we just want to say current server socket.close, because after we know we accepted the client we care about connecting with, we care about chatting with, we don't need to listen to here in this server socket anymore, since the server socket is really only for accepting connections. This client socket, which we won't close here, will then be used to actually keep this connected instance, this active connection, to be able to always send data between our client and server. And in the next video, we'll then also actually use our client socket in here to listen for incoming messages and then emitting these here in our flow. But for now, we are fine with this function. That will be enough to establish a connection. Next up, in our connect to device function, which will be very similar, since we are now in the end on the client's perspective. So the other party launched the server and we are now the client who wants to connect to that server. In here, we again want to return a flow in which we check if we do have permission, Bluetooth connect. If we don't have that, we again throw a security exception. No Bluetooth connect permission. If we do have permission, we now need to connect to the device we actually passed here. And this will be the device we later on clicked on in our list and the UI, which will then pass to our service here. And this time we get the current client socket from using our Bluetooth adapter. Actually, not the Bluetooth adapter. We need to use this Bluetooth device to establish a connection to that. However, this is our domain Bluetooth device and not the Bluetooth device class we actually know from Android and that Android cares about, which is this one. So we need to kind of get the relevant instance of the Android Bluetooth device using our domain Bluetooth device. And we can do this using our Bluetooth adapter .get remote device. And here we need to pass the address of the device we want to get the information of, and that will simply be our device.address. So let's do that. Let's put that on a separate line. And then we can call create RFCOM socket to service record. And this will return a Bluetooth socket, as you can see, and that is the one we want to use here. It will take the UUID, so the same one we now also use to create the server. So here we can say UUID.fromString and passing our service UUID. And that way we now established a connection to our server. After we've done that, we can also stop the discovery, because then there is no point in discovering new devices anymore if we establish such a connection. And we can then also say current client socket, _let to get a null safe instance of that socket. And then we say try catch. We also catch IO exceptions as for the server. Let's give this socket a name of socket. If we do catch an exception, so if something went wrong, we want to close this socket, we want to close the connection. We want to reset the client socket to null, and we want to emit something in this flow, which will be a connection result dot error in this case, because if there is an exception, we know something went wrong. And we just say something like connection was interrupted. If everything goes well in this try block, we want to call socket.connect to connect to the socket. After that, there's also a blocking action, which will block the thread until the connection was established. After that, we want to say emit. This time, connection result, connection established. And then here we can also handle our socket connection. That is, again, something we will do in the next video. Right now, this connection will actually directly abort because this flow will finish emitting values. So Of course, if we don't have this consistent loop that checks for new messages, this flow will finish that we return here, and therefore our connection will also be closed. Because after this flow in here, we want to call that on completion. So either if there is an exception in this flow or it simply finishes, then we want to make sure that we close the connection of our socket. And we also want to call flow on and pass the IO dispatcher. So just making sure we execute this on the IO thread, which is the right one for a Bluetooth connection. We should also do the same for our server connection, by the way. Let's copy this, paste it in here for the server. And that seems to have an issue. Okay, because we did not have a single emit call in this flow. Let's simply add that and say, okay, in here we also emit connection result, connection established, and then it will actually know what we emit in this flow. Cool, so now we have our two main functions to establish a connection. To close a connection, that will be very easy. We just want to use our current client socket.close, current server socket.close, and then setting both these to null again. So we could establish a new connection. If we release this, then we also want to call close connection and to unregister our receivers. Next up, before we can implement this in our UI and actually connect to a device, we need a Bluetooth state receiver or observer or something like that, because we need to listen to state changes in the end. So we want a way to receive a Boolean when we are successfully connected and when the connection was actually interrupted or disconnected. We partly already have this here when this simply throws an exception, but in my experience that wasn't always really reliable, or it often took a little bit of delay. So a way to fix this is to have another broadcast receiver. We can simply take our found device receiver, copy paste that, and call that Bluetooth state receiver. Instead of an on-device function, on-device found function, this will take an on-state changed. And next to a Bluetooth device, this will also give us an is-connected Boolean as a parameter, which we'll then call when this actually changes. What do we receive here? We first of all want to get the device again, using this at the root level here, add the null checks, and then we want to check if the action is Bluetooth device action ACL connected and Bluetooth device action ACL disconnected. So these two actions will be fired when we are either connected or disconnected. In this case, we call onState changed with true, and our device, if it's null, we simply return. In here, we do the same, just with false. We can then go to our Android Bluetooth controller and initialize such a broadcast receiver right here. Private val Bluetooth state receiver, which is a Bluetooth state receiver. Here we get our is connected Boolean and a Bluetooth device like this. And we can then update an is connected state. We don't have that yet in our Bluetooth controller, so let's go in the interface and add that. Val is connected is a state flow of type Boolean. And then back in here, let's actually add that here, is connected. Also add a private variable of that. So a mutable state flow underscore is connected will be of type Boolean, and false initially. Then this one will be is connected as state flow. We don't need that. And in here in our Bluetooth state receiver, when the state changes, we want to update that Boolean state. First of all, I want to check if this device we're trying to connect to is actually in our bonded devices, in our paired devices, or we should actually do this in our connect function when I'm thinking about that. So in connect to device, we want to first of all check if, let's first of all get the Bluetooth device using this. And then in here, we can use our Bluetooth device like that. And before we do this, we want to check if Bluetooth adapter.bonded devices.contains the Bluetooth device. If that is false, so if we are not paired to this device. And by the way, we should do that afterwards, of course, because this will create the pairing dialog which both devices need to accept. First of all, I want to check if our Bluetooth adapter bond devices contains that device already, the Bluetooth device. If that's true, then we want to update our isConnected boolean with isConnected. The reason I check this is because we only want to update the connection state if we actually are paired to that device. Otherwise, I also got these updates from that state receiver if we're not paired, but if we're not paired, we can't really establish a consistent connection. So let's just simply add that check. And else we say we emit an error in an error shared flow or so, which we can also create right here, val errors, which is simply a shared flow of strings. So shared flow is just used to send one-time events and very handy for this scenario. In here, we can then say our errors shared flow will be also a mutable one. So private val underscore errors, mutable shared flow of type string, and then assign that in here, errors.s shared flow. We can then scroll down, and in here we say underscore errors that try emit to emit a value in that shared flow, or we just launch a coroutine here once in a coroutine scope to emit that dispatches IO, and we say errors that emit, and we emit the value can't connect to a non-paired device, and we of course need to call that launch. Like this. Now that we have this receiver and get updates when we're connected or not connected, let's also register that receiver here in init. So we say context register receiver, our Bluetooth state receiver, and we pass an intent filter with the actions we can receive here. On the one hand, that is Bluetooth adapter dot action connection state changed, Bluetooth device dot action ACL connected and disconnected. Like this. And what is the issue here? Intent filter actually only accepts one action as in the constructor. So let's cut these out, just create one like this, call apply, and we can call add action with all these actions we had. So let's call add action, paste this here, rearrange that a bit, and then we can duplicate that to add multiple actions to this intent filter, action ACL, actually Bluetooth device, action ACL connected, and action ACL disconnected, like this. When we then call release, we also want to unregister that Bluetooth state receiver, so we also don't get any memory leaks or so. And that is everything we need to do in our Android Bluetooth controller to be able to connect. Next up, we want to go to our ViewModel, and in here, in our init block, we want to listen to our Bluetooth controller that is connected. I'm going to call on each to listen to each emission is connected. And here we simply want to update our local state, and we set is connected to is connected. We don't have that yet in our local state. Let's implement that in our Bluetooth UI state class. So is connected, which will be, of course, a boolean, false initially, and let's also have an is connecting boolean. So whether we are currently connecting to show the progress spinner. In here, that will work just fine. We can then launch this flow in our ViewModel scope to also listen to these emissions. And let's also go back to our UI state and have an error message, which is a nullable string, which we can pass. So when an error happens in our Bluetooth controller, we also want to update our UI, of course, show toast or so. So here in our errors shared flow, on each error, we want to update our state, call it copy, error message is error. And then we also call launch in ViewModel scope. Now next up, we need to establish a connection in our ViewModel when we click on one device in our list. Since we need this logic for two scenarios, and on the one hand, if we launch a server, and if we did not launch a server but connect to a launched server, we want to have the same collection logic in the flow, which is why I want to create this a shared function. So just a helper function to not need to write this logic twice. This will extend flow of type connection result and will be called just listen. We'll return a job. So the job we launched this observation in, and in here we then return on each. So we listen to each connection result emission, and we can check when result. Press Alt Enter to add the remaining branches. Right now we only have these two. If the connection was established, you want to update our state correspondingly. Is connected will be true. Is connecting will be false. And also our error message can be reset to null. We can copy this, paste it for the case when we have an error. In this case, we're of course not connected. We also are not connecting anymore, and the error message will be result.message. Then after this on each operator, which is here, we want to call a .catch to catch throwables or exceptions. When we throw something in the flow, we can catch that here. In that case, we want to make sure that our connections are closed. So Bluetooth controller, close connection. And we also want to update our state again. Make sure that we're not connected anymore, that we're not connecting anymore. And the error message remains unchanged. And then we simply call launch in ViewModel scope. And that will return a job that we can then keep track of and also cancel if we want to cancel the connection. Since if we cancel the job this flow is collected in, then that will also mean that we cancel or that we close the connection in our Bluetooth controller here, since this onCompletion will be called when the job will be canceled. It will contain a cancellation exception. We also close the connection here just to be sure, and then we will basically stop listening. In our ViewModel on cleared function, we want to call Bluetooth controller release to just release all resources when the ViewModel leaves the backstack. And then we want to have two functions. On the one hand, connect to device, where we'll pass a Bluetooth device, the domain one. We say state update it copy is connecting is true. We launch this, so initially we have this is connecting being equal to true, and it will be reset to false when the connection has been established here. So here we will say Bluetooth controller that try, actually just connect to device, pass our device, and then we'll listen to this. So we just launch the flow using our extension function down here, and the result of this will be saved in a job, which we have up here. Private var device connection job, like this, null by default. And when we then connect, we simply save this in here, device connection job, so that we can cancel this job when we want to disconnect. So when we disconnect, function disconnect from device, which will simply disconnect from the current connection. Here we say device connection job.cancel Bluetooth controller that close connection, and we update our state with it copy is connecting is false and is connected is also false. Next up, we then need a function to listen for incoming connections. So function wait for incoming connections, so to launch a server in the end. Here we again say state update is connecting is true. So we show the progress spinner, and we then set our device connection job equal to our Bluetooth controller dot start Bluetooth server dot listen, like this. So we can reuse the function listen here for both these same flows. And then in our UI, so main activity, here in our surface where we just show the device screen right now, we want to have a when expression because when the state is connecting, we want to show our progress spinner UI. So we just show box, modifier, fill max size. And in here, we will have a circular progress indicator, which we align in the center. So modifier is modifier align center. And else, if our state is, well, let's just say else, then we want to show our device screen. And then we also want to add a launched effect block, which triggers every single time our error message changes. So we can easily show that as a toast. So we can say state error message. If that's not null, we show a toast. We pass the application context, we pass the message and toast, length long, call that show, and we are good. And let's actually make this a column so we can also add a little text that we're connecting. So let's say modify fill max size. The horizontal alignment will be center horizontally, and the vertical one will also be center. So we just center the content in the column. We can then get rid of this, and we can add a text connecting like this. And just for testing, let's add another launched effect block here that triggers when the is connected Boolean changes. Where we can check if we are connected. We can also just show a toast. That is really just for testing here that we see that this is working. So you are connected. Because as for now, we're of course not able to exchange chat messages yet. That is what we'll do in the next video. And then when we click on, in our device screen, on a device, so on device clicked, and we get a Bluetooth device, our domain device. And when we click on our on start server, so we of course need a button to start the server. And then we also want to pass lambdas here, so we can send these actions to the ViewModel. For the start server button, we can copy this button in our row, paste it here, say on start server, and we say start server. We then want to go in here for this Bluetooth device list, on click, and set this to on device click. Then in main activity, we say on device click is ViewModel connect to device, and on start server will be ViewModel wait for incoming connections. So I think we are ready to try this out and launch the app on both the devices. So the app that we just built with our connection logic, you can see these devices are not paired. This left one is my Pixel 6, which does not contain the OnePlus 8, which is the red one. And this one does not contain the Pixel 6 in the paired devices list. If we now click start scan on my Pixel 6, then here our OnePlus 8 will actually appear. And first of all, before we can do this, here we need to launch the server. So let's click start server. You can see connecting, and on the left side, we then click on OnePlus 8 connecting as well. And okay, it says can't connect to a non-paired device. We need to fix this error message probably, but you can see the pairing dialog actually shows up. And if we now pair on both sides, then yes, we get the toast, you're connected, which is exactly what we want. So the only thing we need to fix at the end is, just the pairing error message, which should only come after the pairing dialog or not at all. But you can see the connection logic is working perfectly fine. We now have an established connection, or actually not, because the connection was closed, since we don't block it as long as we want to listen for data. But that is exactly what we want to do in the next video. So if you enjoyed this course so far, then also take a look in this video's description, where you will find more advanced Android premium courses on my website, so you can really learn the things you need as an Android developer in the industry. Apart from that, you will also find the next part here when it's out, and then I wish you an amazing rest of your week. See you back in that next part. Bye bye.